Thank you. See you later in the panel.
Okay, so now it's time to move to the second presentation of this session. The paper is entitled Cloud Programming Languages and Infrastructure from Code, an empirical study, and the floor is yours.
Thank you. So, hi, my name is Georg Simhandl, and I will present the results of an empirical study on cloud programming languages and infrastructure from code. I did this study together with Zdun, who is heading the research group Software Architecture at the Faculty of Computer Science at the University of Vienna, where I spent the last years as a postdoc and later as a senior researcher. So, infrastructure from code is a new approach to automation of DevOps and can be understood as an advancement of infrastructure as code. One of its key concepts is to provide a higher level of abstraction facilitated by new programming languages or software development kits or frameworks using general-purpose programming languages. Both automatically generate the necessary code and configurations to provision the infrastructure and deploy the application and manage the cloud services. So cloud-native programming languages are specifically designed to leverage distributed computing concepts for cloud computing especially, while general-purpose programming languages usually lack this concept. So on one hand, there are new programming languages. They can provide powerful abstractions, but it's unknown, or we don't know how it affects the cognitive load of developers, and we don't know if it improves overall productivity and system maintainability. So, to close this research gap, we conducted a controlled experiment with 40 participants and evaluated supporting factors and barriers with a qualitative approach. So let's have a look at the evolution of infrastructure as code to infrastructure from code. Infrastructure as code has its roots in the mid-2000s, starting with the release of AWS Elastic Compute, and along with all the web frameworks still popular today like Rails, Ruby on Rails, etc. And the first and second generation of infrastructure as code used domain-specific languages like Chef, Puppet, and Ansible to configure infrastructure. As the systems got more complex, this approach often led to repetitive and verbose configurations. The third generation of infrastructure as code, like Pulumi or CDK, Cloud Development Kit, uses general-purpose languages to solve this problem. And with the growing number of cloud resources, the infrastructure configurations and the runtime code are further separated. This also had a huge impact on the divide between development and operation teams. Infrastructures from code tries to close this gap, this DevOps gap. Instead of separate infrastructure configurations and application code, it leaves only application code. And the infrastructure configurations are completely derived from code. So it's a very highly dynamic area. As you see, it's very recent development. I didn't put all the infrastructure from code solutions there. We thoroughly evaluated a lot of solutions there, and it's also not binarily classifiable. So recently, generative infrastructure from code approaches emerged like in September and October even, and we also see some scan-based approaches, annotation-based approaches, and they quickly change. So, for example, Curlfo, one of the examples, they used annotations, and they switched to an SDK approach recently. So a lot of dynamics here. There are two remarkable solution paths in infrastructure from code, which is the software development kit or SDK or framework-based approach, which is can be seen as the natural next step in evolution, and programming languages based approaches on the other hand. After a thorough evaluation of the many EFC or infrastructure from code approaches, we selected Nitric and Wing. Nitric representing the SDK approach and Wing Lang the programming language based approach. So the criteria were like availability, cloud agnostic support, production readiness, etc. Let's talk about this Nitric, the SDK approach. It's similar to a lot of other SDK approaches, which provides cloud service abstractions using SDK. And this provides developers object storage, API gateways, asynchronous messaging to easily implement the applications. Using a CLI or a server, the infrastructure as code is generated from the application code. And with a provisioning engine like Terraform, the infrastructure can be configured and provisioned on the cloud. One aspect I would like to mention is that Nitric provides automations for usually quite challenging tasks like IAM, like identity and access management, and to provide some very easy to control system like just providing a method for certain roles and policies are even created automatically. On the other hand, we have Wing, which is a new programming language, which introduces two major concepts. I just cannot go into all the details, but one of these major differences, and they're really different. And the first look is look similar, but they in depth they're very, very different. It's in-flight code, which implements application behavior like handling API requests, processing queue messages, and these can be easily packaged and executed on cloud computing platforms, including serverless, AWS, Lambda, even Kubernetes or virtual machines. The second, the so-called pre-flight code, runs only once at compile time and compiles or transpiles actually this code to infrastructure configurations like Terraform. So, considering the potential of this infrastructure from code, it's necessary to evaluate its efficacy, and especially for newcomers, novices. Therefore, our primary research question is what are the developers' productivity or effectiveness and usability of the two different infrastructure from code concepts. So how do they compare? In particular, we are interested in how developers who are completely new to the cloud or somehow new to cloud development understand the concepts of approaches and how correct and effective developers are with these approaches implementing a complete application, not a toy example or a smaller example, and how they link generated infrastructure as code back to the abstraction of the code. So whenever code is generated, we know that the generated code is sometimes not so comprehensible. And finally, we wanted to know what are the barriers and supporting factors related to usability. So this is very important for language engineers. What hinders developers adopting a language, or what are the supporting factors? To evaluate these dependent variables like time to complete, a task and correctness of the task, etc., we designed a controlled two-group within subject experiment, whereas the major independent variables were the treatment group solution approach. So what you can see here is that we the procedure of the experiment was that we informed the students about, we recruited students from our faculty about the study information. They had to sign the declaration of consent or withdraw, the data protection, pseudonymization sheet. And then we asked the independent variables in a pre-experiment, like age, the prior knowledge, which work experience, etc. And then they had to do 4 tasks with about 2 subtasks each, whereas they had worked on both approaches. And in Group A, they first started with the programming language-based approach, and we assessed concept comprehension of the programming language-based approach using multiple choice questions and or open questions. Then they had to implement or extend an existing application. And in the third task, they switched to the SDK-based approach, where they had to trace back infrastructure as code, like Terraform, generated Terraform code configuration to the code. To compare both approaches in implementing, because this was one of the major interests of us, we also asked the participants to implement the delete request handler for or enhance the program. So this is the Group B, which is just switched the two the order. Talking about participants, as I said, we recruited the participants at the Faculty of Computer Science. In total, we counted 42 participants. One opted out, another didn't finish the experiment, so we had to rule them out. And the remaining 40 participants were evenly divided into 2 groups of 20. So there were 3 females, 17 males, and about 8 and 10 in the other group. They were enrolled in a master's program in computer science, and the rest in a bachelor program. So we had quite a variety of majors, like computer science, data science, business informatics, and the 2 groups were quite homogeneous. What we see here is that there's also the cloud service provider experience is quite limited. So none or very limited. They only had first look in cloud service providers. So this is what we're actually also looking for in the novices. So to assess the understandability of the key concepts of infrastructure from code in terms of correctness and time to complete the tasks, we prepared a small application. It's an URL shortened like the tiny URL, maybe you know, to shorten URLs if they get too long. And we found that this is one of the applications or examples can be found in many of these cloud programming language approaches. We did this for both approaches, like Wing and Nitric. And I don't want to go through all the details, but here we see the in-flight code for the request handler, the GET request handler on the one side, which the participants had to comprehend and answer some multiple choice questions. And on the other hand, there was also one of the concepts of nitric, which is called implied access, to make IAM or identity and access management easier, using a method here, it's allow very easily, which generates then the infrastructure from code or Terraform configurations automatically. Both implementations use API gateway, simple key volume storage, or bucket called in Wing, and an encrypted secret storage on 3 cloud services. This is a potential or an excerpt of a potential solution for both, where we asked participants to implement a serverless function for Wing, for the programming language-based approach, and on the other hand, we asked participants to implement the delete request handler for the SDK-based approach. Here, we evaluated how they understood also the concept of implied access, meaning how they configure or code the access, the get, set, and delete attributes here. In the third tasks, what I introduced, they had to trace back the infrastructure as code to the code, and this also illustrates how easily the code is the infrastructure as code configurations, like Terraform configurations, are derived from code. So you have some, for example, an get request handler, an API gateway, and you compile, or it's actually transpile it to Terraform, using also a provider. In that case, it's AWS. By the way, we took only cloud programming language or approaches, infrastructure from code approaches into account, which were cloud agnostic. So what we think it's a huge benefit of these approaches, of these abstractions. So results. To sum up the results, I'll just pick one of the highlights here is first the concept comprehensions. How do participants comprehend the underlying concept? And we see that only like 62 said that the function which they had to create can be executed during pre-flight, and this. So the basic assumption was kind of not understood how pre-flight and in-flight work together, but we see it later on that the interaction between these two basic concepts help participants to create more correct implementations. And the SDK, on the SDK-based approach, we evaluated primarily the implied permission concept, and also here it was quite difficult for participants to comprehend the underlying concept. And so, in general, we also evaluated the effect size, so meaning statistical tests, and we've seen there's no significant difference, or it's no difference in both approaches. So, comparing the correctness of the solutions the participants submitted or provided, both approaches yield similar results as well. So they spent a bit more time on the programming language-based approach, and what is interesting, this is indicated by the apparent trends, the red line here, that the correctness increases over time, while the correctness more or less stays the same with more time provided or taken. This is the summary of the statistical tests, what we see here is that I just jump right to the conclusions, so to experimental findings. What you see is that programming language-based and SDK-based approaches involve similar effectiveness, while the programming language-based approach was moderately less efficient but increased correctness with time spent on programming. And tracing back the infrastructure from code to the abstraction to code was very challenging in both cases. So as we see, there is not really a significant difference between these both approaches, and we wanted to know what's the feedback from the users, what is the feedback from the participants. So this also shows somehow the classical empirical studies limitations if you just look at correctness and completion time. So what we did is a thematic analysis of the post-hoc survey, and thank you. And there were 21 themes emerging from the survey using about 178 initial codes. And we used this method to understand also the experience with this IFC infrastructure from code approaches, and to highlight some of the major themes here is, for example, accessible onboarding is very important as a supporting factor. Participants, like the majority, highlighted that the availability of good tutorials, comprehensive documentation, easy to set up, processes are key, like 32 mentions here. And the programming language-based approach is easy to use once the basic concepts are understood. And again here, comprehensive documentation is key. So you can introduce quite new programming language features if you provide comprehensive documentation and examples. Same goes for friendly user interfaces, and what I also want to mention here is that both approaches used kind of a local cloud simulation, and this also helped. There are two more themes I want to pick out here. First is security concerns. It's very important for cloud native programming, and in this case we also are mapped with the thematic analysis the experience from the users or the participants to their perceived security concerns or perceived risks. And what we see here is that the risk of data breaches and attacks is very important to consider. And also there is a fear or the risk of dependency on cloud service providers. So this is what participants mention quite often, that they either trust in cloud service providers or they feel quite dependent. What we see here is that intermediate and beginners are quite leaning towards the dependency, and novices, they just, okay, cloud service providers we can trust, they are here for taking care of security and also privacy protection. Another very important aspect was uncertain cloud costs. We asked participants as well how they would estimate cloud costs. And we see that for this very simple application for 1,000, 10,000, and 1 million requests per day, they had quite different estimates here. To sum up the findings, there were 5 major findings in the emerging from the thematic analysis. So there is usually what hinders in adopting cloud programming language or language in general is insufficient support resources. There is also mentioned, what was quite interesting, that the need for modular architecture for larger applications. So when we ask participants how they would manage it, they suggested kind of a microservice-based solution. There is a lack of infrastructure traceability, tooling, and testing support as well. There is basic testing support available, but that can be enhanced or should be enhanced. As mentioned, cloud cost is a huge topic. So the fear and the risk to spend too much on cloud services is evident. Concluding the talk, we did a controlled experiment and a thematic analysis. We found that the programming language-based approach was moderately less efficient, but increased correctness with time spent on programming. And we've seen that tracing back infrastructure from code to code was quite challenging. And what we suggest, or what we can conclude for the future research is that we suggest to work on enhancing local cloud emulation, expanding cloud integration support, developing tools for code to infrastructure traceability, cost estimation, and systematic security checks. Thank you.
Thank you very much. So is there any question in the room? Maybe I can kick off this Q&A session by my question. I actually discovered with your talk what is infrastructure from code. I didn't know that concept before. And I mean, my question is more general than the work that you did explicitly, but it's more on the concept itself. And I was just wondering from where this is coming in terms of motivation. What I mean by this is that in software engineering in general, we try to separate the concerns. Yeah. And here my feeling is that we try to put together two very different concerns. And especially because there is one drawback about the traceability in between the two, I'm a bit worried about this trend going on that direction. So do you have any insight about this? What was the motivation for putting together the code and the information for allocating the infrastructure? I mean, do you have any insight on this?
Yeah, so infrastructure from code is very new, and it emerged about as a term like 3-4 years ago, and eventually in 2 years we've seen the first prototypes from infrastructure from code. And the main aim was to have one language, programming language, one combined solution for both infrastructure provisioning, which is automated, and also to avoid repetitive tasks in configuring Terraform. If you see it, Terraform configurations, they can become very, very large, even in lines of codes larger than the application itself. To automate the provisioning and also to automate this Terraform or also Pulumi configurations, this solution approaches try to make it as easy as possible with the same language, in the same language. So it's only one language. This is the one, so you don't have to learn two different approaches. If you separate to concerns or not, it's up to you. You can also put it in different structures, folders, whatever. So it's not too tight. On the other hand, we see a shift from the boxes to the lines. So with all the cloud service functionalities already built in, you start to focus on how to connect the functionalities like message queues and REST APIs, and do not have to take care too much about the implementation details here in comparison to general purpose languages. Yeah.
Okay, thank you very much. Any maybe last question? We are running a bit late, but if there is a very last question, maybe we can take it. No? So in that case, I propose that we thank again the presenter. Thank you very much for the presentation.